Today's Flipped 5 is talking about Mendel's actual experiments and the observations he made that really caught his attention and made him start to think, what is going on here? So, we just for our do now talked briefly about this. Why did he use pea plants? And so we went over this. He used pea plants. There are lots of very visible traits. They're tall or short. There's no in-between traits, which is really interesting. He could control the pollination, and the pea plants have a quick life cycle. They grow quickly, they reproduce quickly. Okay, so let's see what he did. Oh, these are all the traits. We'll go past those. Okay, so Mendel, as he was tending the gardens, he saw these patterns. Here's what he saw. He said, okay, well, Mendel's pea plants. And we're just going to use height as the characteristic to talk about today because it's easy to draw and it's the one the textbooks use for the example. So he would take, this is my kind of shorthand, tall pea plant. A tall pea plant and cross it with another tall pea plant, and he would get all tall plants, right? Pretty obvious. No surprise there. Yeah, but we're doing this first. So these problems here are showing, he's setting up kind of the background information. He saw these other patterns, but this is when he went back and he's setting up a control, right? He's setting up the data to say, okay, these tall plants always produce tall plants, and he's going to call them true breeding tall. And so he can set aside these seeds because he knows that these plants, generation after generation, always make other tall plants, right? He's trying to control for variables. He knows these are true breeding tall, which, by the way, we're going to end up calling purebred this week. Purebred. Okay, so these are true breeding tall plants. No surprise. Now, then he would take short plants. They're kind of more short and bushy rather than tall and viney. Cross a short plant with a short plant, and he gets, of course, all short plants. Again, no surprise here. And so these are going to be his true breeding short plants. So these are the true breeding or the purebred short plants. So no surprise, right? No big deal. But this is the background he needed to do the next piece. So here's what he does next. Okay. All right, so then these are the patterns that really caught his attention later. So what happens is he takes a true breeding tall plant. Okay? We'll call it true breeding tall plant. And he crosses it with the true breeding short plant. True short. And guess what he gets? He gets all tall plants. All tall plants. And that's why we wanted to make sure they were true breeding, because he wanted to make sure that he knew that it was true breeding tall crossing with true breeding short, and he gets all tall plants. Now this kind of bothered him because he knows that if you take the pollen from this plant and the flower from this plant, you should be getting genes from both parents. So why are we not seeing the short trait? And of course, sorry, he didn't know about genes. He just called them factors. He said there must be some sort of factor that's being passed down. So he thought, well, that's very strange. This tall trait is dominating. It's covering the short trait. And so he called this a dominant trait because it's covering the short trait. And it wasn't just a mistake. He did it over and over. So then what he's going to do, so this is going to be called the, this is the parent generation, P1 for parent generation. And then this is going to be called the F1, or the first filial, the first generation of children. And so what he's going to do next, he's going to cross two of these F1 plants because he suspects that the short trait might be hidden in there somewhere. And what does he get when he crosses these two F1 generations? He gets oh, good question. So the question is, does it matter which one's the mom and which one's the dad? Which one's the flower and which one's the pollen? It does not matter. In these cases, it's just one from each parent. You know what? He doesn't get all tall. He gets a ratio overall of 3-to-1 tall to short. Tall, 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 short. Right, so in this case, the small plants in pea plants, in Mendel's pea plants, the short plant is what we're going to call recessive. It's a trait that gets hidden, right? So this is, the short is going to be a recessive trait. But this confirms what he suspected, which is that those traits were hidden in there. They were hiding. They were being covered up. And so he kind of goes back over it and says, well, if you get one factor, if you get one bit of information from each parent, these are true breeding tall. We know that both of the parents from this plant were big T, right? We know big T is going to be tall. We know that these guys are tall and these guys are tall. These guys are all tall. They get tall factors from both parents because that's the way he set up the experiment. True breeding tall are going to have two tall genes. And then these guys are short. Now, instead of using an S, we're going to use a little t to show that the short t gets covered up by the tall t. Okay? So then what we can do, we know this is big T, big T. This is little t, little t. Now check this out. I'm going to pause for a minute because there's some questions. And then we'll see what happens next. Okay, so we moved on. So we said this is true breeding tall. We know it's big T because he made sure it was that way. This one's little t, little t. So if you get one factor from one parent, we're just going to call them mom and dad, even though plants aren't moms and dads, and one from the other has to be a big T and a little t, right? Or the other possibility, so you could get this big T and this little t. Or you could get this big T and this little t. Or you could get this one and this one, or you could get this one and this one. But anyways, the end product is the only possibility you could possibly get is a big T and a little t. And since in pea plants, tall is the dominant trait and will always cover up that short one, you get all tall. But in the F1 generation, these guys each have one tall and one short factor, or gene, or allele, as we're going to call them. So what does that mean? So if we look at the outcome, if you get one from mom and one from dad, you could get a big T and a big T. Here, we're going to make this one a different color so we can see the difference. Or you could get a big T, whoops, and a little t. Or you can get a big T and a little t. Or you can get a little t and a little t. Okay, so those are the 4 different possibilities of what you could get. So what he saw with his eyes is that in that F2 generation, the second generation, here is that short trait that he knew was hidden in there, finally came out. Because it can only come out if you get 2 shorts, not being covered up by a tall. And, as was predicted by these boys over here, this technically is a purebred. Next week we're going to get a different name, because for us to have 2 hybrids produce a purebred is a little weird, but that's right. purebred, hybrid, hybrid, and then a purebred. So you ended up with a true breeding tall, a true breeding short, and then 2 hybrids. Crazy. Now, one more quick thing, and then you get to practice. Now, that's a lot of probability. Fortunately, years later, a person named Reginald Punnett came up with a nice, easier mathematical way to show this. So if we can go to our next page here, my next page is. Okay, so finally, a few years later, as Tim and Mulvey told us, a man named Reginald Punnett, but we don't care about that, came up with a much simpler way to diagram and show all of the possibilities. It turns out, you'll be happy to know, the math is easy because you have 2 parents, and each parent has 2 chromosomes. So it turns out that in any given cross, there's just 4 possibilities. So we can put this here. Let's do the one we just did. Starting from scratch, we had the true breeding tall and the true breeding short. If you get 1 gene from each parent, everybody gets a little t from this parent, and everybody gets a big T from this parent, and your only possibility is 100% will be tall, 100% are also hybrid, okay? Then, when we did our F2 cross, we make our Punnett square here, and this parent is big T, little t, and this parent is big T, little t. So let's look at the probability, again, the probability, not the guarantee, of what the children could be. So this could be a big T, one from this parent, and a big T. True breeding tall. And then this one right here, yep, that one's a hybrid. And then this one, little t, big T. And then this one, little t, little t. And so there we see 25% true breeding tall, 25% true breeding short, 50% hybrid, but 3 tall to 1 short. So you're going to practice these now. I know it's a little bit confusing, but this is one of those things that even if it kind of makes sense or even if it doesn't make sense at all, doing it on the paper will help get you there. So we are way over 5 minutes for our flipped 5, but that's how we do Punnett squares, and that's what we're going to be practicing for the rest of the week.